Welcome to Brilliant Minds Unlocked. Imagine this massive 27-kilometer underground ring right beneath the French-Swiss border. We're talking about CERN's Large Hadron Collider, the LHC. And one source we looked at calls it get this, a cathedral of steel and superconductor, built, it says, not just to recreate the universe's first moments, but to listen to the silence within the atom. Pretty poetic, huh?
It really is. That phrase just perfectly captures the sheer scale and the ambition of it all. The LHC is, well, it's the most powerful scientific instrument humanity's ever built, trying to answer the biggest questions we have about the cosmos.
Absolutely. But today we're zooming in, focusing on a kind of surgical team working inside this massive machine, a really specialized group, this collaboration known by a pretty cryptic name, 3IIS.
That's right, 3IIS.
And their mission, this is the focus for our deep dive today. It sounds pretty wild. They're basically hunting for ghosts.
Ghosts? Well, in a manner of speaking, yes.
Yeah, like ghosts of other dimensions, maybe shadow particles, evidence that our reality, might just be this tiny bubble with cracks in it inside something way bigger. We're looking at what 3i Atlas is doing right now to find those cracks in the standard model of particle physics.
Okay, before we jump right into the hunt, we probably need to lay a little groundwork to find the pieces.
Good idea.
So, ATLA. That stands for a toroidal LHC apparatus. If you haven't seen pictures, just imagine this enormous cylinder. 46 meters long, weighs 7,000 tons. It's built with all these concentric layers of detectors and instruments.
Right. Our sources describe it as basically the most complex digital camera ever made. Though it's not taking photos like we think of them, is it? More like analyzing the aftermath.
Exactly. It's not snapping pictures of the collisions. It's meticulously dissecting the debris field after billions of protons smash together every single second. It measures the energy, the momentum, the type of every tiny particle fragment that flies out. It's all about reconstruction.
Got it. So what about the 3I part? That sounds much less exciting. Institute for Innovation, Instrumentation, and Interdisciplinarity.
Yes. Which, according to your sources, is kind of the point, isn't it? It's meant to sound a bit bland.
Yeah.
Academic.
A shield, they called it.
A shield, exactly.
Okay.
Because behind that name, it's really focused on what you might call blue sky physics. The 3I mission is all about pushing the technology, developing new ways to see things, to analyze the most exotic stuff. And crucially, they're the ones refining the methods to spot signals that aren't supposed to be there. Those little statistical hiccups others might just write off as noise.
Okay, let's unpack that official hunt then. Because the standard model, it's amazing, right? Explains almost everything we see in particle interactions.
Pretty much, yeah. 99.9%. It's a masterpiece.
But we know it's incomplete. So what are the big targets? The main things 3i Atlas is officially looking for right now to sort of patch those holes.
Well, the targets are definitely game changers. First up, they're aggressively hunting for supersymmetry, SUSY for short. Now, this isn't just one new particle. It's a whole theoretical framework suggesting every particle we know has a hidden, much heavier twin, a shadow particle.
A twin, so like the electron has a secret heavy buddy. Why haven't we seen these twins then? And, why does it matter?
Because they must be incredibly massive. You need the LHC's huge energy to even have a chance of creating them. And the significance, it's enormous. These heavy, invisible shadow particles, the lightest one would probably be stable, wouldn't interact much. It could be the dark matter we've been searching for.
Wow, okay. So finding SUSY potentially solves two massive problems at once. What stabilizes the Higgs boson and what's holding galaxies together?
Precisely. Connects those dots. Finding it would absolutely kickstart a new era in physics.
Okay, that's huge. Target number 2 sounds even weirder. Extra dimensions. How on earth do you hunt for dimensions we can't even perceive?
Yeah, it does sound like something out of a movie. It ties directly into string theory, mostly. The idea is maybe space isn't just the 3 dimensions we walk around in. Maybe there are others, tiny ones, curled up really small. And the LHC, in those super high-energy collisions, might just momentarily jiggle them, uncurl them a tiny bit.
We wouldn't see the dimension itself, though.
No, probably not directly. But we might see the effects, like imagine energy just vanishing from the detector. Gone.
Gone where?
Maybe leaking away into one of those hidden dimensions. Gravity is super weak in our dimensions, right? Maybe it's strong somewhere else, and energy follows it. So if the detectors see a collision where the energy just doesn't add up, a big imbalance, that could be a sign of elsewhere.
Right, energy just missing. Okay, the third target you mentioned is more straightforward, trying to directly create actual dark matter particles. And the fourth one...
The fourth. This one's the most open-ended. And maybe for 3i especially, the most thrilling is just anomalies. This is the catch-all for anything unexpected, any weird blip in the data, any measurement that just doesn't quite fit the standard model's predictions. One source called it finding a footprint where no one should be walking. That's where the real potential for totally new discoveries lies.
And this is where it gets really juicy, because the LHC has seen these footprints before, hasn't it? These hints, these whispers. The most famous one was that phantom particle episode, right? The 750 GeV diffeton bump back in 2015-2016.
Oh yeah, that completely gripped the physics world for months. Both main detectors, ATLS and CMS, saw it independently. A small but statistically significant bump, an excess of pairs of photons adding up to 750 gigaelectron volts of energy.
And just to give people context, the 750 GeV, the Higgs boson, is about 125 GeV. So this thing, if real, would have been like 6 times heavier. The sheer energy and the fact it decayed into photons, pure light, it screamed new physics, something totally outside the standard model.
Exactly. Speculation went absolutely wild. Was it a heavier Higgs, a new kind of force carrier, a Z prime? People published something like over 500 theoretical papers about it in just a few months. And 3 ATLS. They were right in the thick of analyzing that data using their advanced filtering methods.
But then, poof, vanished. More data came in during 2016, and the bump just flattened out, called a statistical fluctuation, a fluke. But the question that hangs in the air, the one our sources brought up, is pretty profound. What if it wasn't just noise? What if it was, and I quote, a signal from a reality that was briefly, accidentally, tuned to our own?
Exactly. And that sort of paranoia, maybe, that fear of having glimpsed something real and then losing it, that's part of what drives the 3I mission today. And it's not just ancient history. There are other persistent puzzles right now that highlight why we need 3I's specific expertise, like the muon smile.
Ah, the muon G2 experiment. Okay, quick recap for listeners. What's a muon, and why is its magnetic wobble, its smile, such a big deal?
Right. So the muon is basically the electron's heavier cousin. It has charge, it spins, and because it spins, it acts like a tiny magnet. Now, its magnetic strength, or its magnetic moment, is affected by this whole quantum foam of virtual particles popping in and out of existence around it. The standard model predicts exactly how much it should wobble in a magnetic field.
Okay.
The muon G2 experiment measures that wobble incredibly precisely. And every time they measure it, it's consistently just slightly off from the standard model prediction. Tiny deviation, but statistically it's getting really significant.
So the math says the wobble should be X, but the measurement keeps saying X plus a tiny bit more. And that tiny bit has to come from something the standard model doesn't know about, some new force or particle messing with it.
That's the strong implication, yes. And 3 ATLS, well, they're the team tasked with taking that clue from the outside, this muon smiling at us and trying to force whatever new physics is causing it to show its face inside the LHC's collisions.
Okay, and this whole chase, this hunt for anomalies, it leads to some interesting whispers, doesn't it? About things like the heavy ion runs or the low energy calibration runs at the LHC. Officially, that's just routine stuff.
Officially, yes. But some insiders, according to the sources, suggest these quieter periods, these silent runs, might sometimes be cover for, let's say, highly classified, off-the-books experiments, directed specifically by the 3 ATLS teams.
So the idea is maybe they're not even hunting for particles during those runs.
Perhaps not primarily. The theory is they might be using those moments, away from the main high-energy spotlight, to quietly test for other things. Maybe looking for subtle temporal distortions or dimensional vibrations, trying to replicate maybe previous strange results under more controlled conditions. It's a fascinating thought, the most exotic stuff happening during the boring bits.
It really is.
And these kinds of technological whispers, these hints of something more going on, they definitely fuel the wilder theories surrounding 3I's work.
Okay, let's go there. Time to dive down the rabbit hole, because the stakes people imagine go way beyond just finding new particles. The biggest theory, probably the most popular one, is the Stargate hypothesis. The idea that the LHC isn't just studying extra dimensions, but it's actually intended, maybe secretly, to open them.
This theory leans heavily on some, let's call it, circumstantial evidence that proponents find compelling. They always point to that big statue of the Hindu god Shiva, the destroyer of worlds, right there at the CERN entrance. They see it as like an admission of the power they're playing with.
Right, and they also pick apart things like the opening ceremony for one of the LHC runs back in 2016, interpreting the performance art and imagery not just as art, but as some kind of esoteric, maybe even occult ritual acknowledging dimensional manipulation. It sounds far-fetched, but these visuals clearly feed a certain narrative.
They do. And the most extreme version of this theory, it suggests 3I Atlas actually has a secret subgroup whose whole job is to analyze the collision data for non-terrestrial communication. Like messages embedded in the debris. They're not just finding particles, they're listening for a reply from whatever's on the other side.
Listening for a reply. Oh, okay. Related to that, but maybe even more existentially unsettling, is the time manipulation postulate. How could smashing protons possibly affect time itself?
Well, the argument goes something like this. The LHC recreates the conditions of the very early universe, fractions of a second after the Big Bang. The theory suggests that by doing this, by poking at the fabric of space-time under such extreme conditions, they might be causing tiny localized ripples in time. Glitches, they call them.
Glitches in time. And this connects to the Mandela effect thing, doesn't it? That idea of collective false memories.
Exactly. Some theorists propose that these widespread false memories, people remembering movie lines wrong or logos differently, aren't just memory errors. They think these are the residual side effects. The typos left behind after CERN, maybe 3I specifically, had to subtly edit reality to prevent some future disaster we never even knew about.
So we're living in the slightly edited version.
Yeah.
That's a mind bender.
It is. The sheer audacity of it is why the theory persists. But there's another fear. Less about physics and more philosophical. The suppression conspiracy.
This one suggests 3I Atlas is on some kind of crusade, a militant materialism crusade.
Yeah, that's the term used. The fear here is that the ultimate goal isn't just discovery, it's a philosophical statement. To use the power of science, the LHC, to definitively prove the universe is just a cold mechanical accident. No room for, soul or purpose or God. It paints the scientists almost as high priests of atheism, working in their underground temple to disprove anything beyond the material.
It's a really powerful counter-narrative. The fear isn't about what they might accidentally unleash, but what they intend to declare. Okay, amidst all these theories and whispers, let's get back to the concrete stuff. The future. The big upgrade. The high luminosity LHC. The HL-LHC. Scheduled for around 2029.
Yes, the HL-LHC. This is the real game changer for the next decade or two. And it's important to understand it's not primarily about more energy, slamming protons harder. It's about density, luminosity.
Right. So why is luminosity, the sheer number of collisions, more important than raw power at this stage?
Because the things they're hunting for, these potential CUSY particles, signs of extra dimensions, weird anomalies, they're expected to be incredibly rare, if they exist at all. By cranking up the density of the proton beams, you multiply the number of collisions happening per second by about a factor of 10. This massive flood of data basically changes the odds. It shifts the hunt from being, hopeful to potentially decisive. If these rare things are possible, the HL-LHC should produce enough of them to be statistically undeniable.
Makes sense. More lottery tickets means a better chance of winning. And 3I is right at the heart of developing the tech needed to actually handle this data tsunami, right?
Absolutely. They need detectors that can survive insane radiation levels, so new silicon trackers, new types of calorimeters. But maybe the biggest leap, the one that really ties into 3I's expertise, is developing the trigger systems. These incredibly fast, smart systems, increasingly using artificial intelligence.
Yeah.
Because you simply can't save all the data, billions of collisions per second. The AI has to make decisions in nanoseconds. Is this event interesting? Is it weird? Save it. Is it boring? Standard stuff? Ignore it.
Which brings us neatly to this idea of the AI oracle. We're essentially teaching machines to look for things we don't even know how to describe. The unknown unknowns.
We have to. The sheer volume of data from HL-LHC will be impossible for humans alone to sift through effectively. So the AI is being trained not just to find specific predicted particles, but to spot patterns. Patterns that might be too subtle, too complex, maybe too non-human for us to easily recognize. Potentially that's how you'd spot something truly alien, like that communication signal theory.
But that dependence creates a huge risk, doesn't it? Relying on these intelligent black boxes, as the sources call them. What happens if the AI flags something as critically important, but it can't explain why in a way we understand?
That is the massive scientific and frankly ethical question looming over the HL-LHC era. What if the AI synthesizes some pattern, maybe even decodes a message, like in the Wilder theories, and it determines, based on its logic, that we humans, that we don't need to know, or that the information is too dangerous, or maybe just fundamentally beyond our comprehension?
That's genuinely chilling. Okay, bringing it back to right now. The LHC is running currently. Run 3 started in 2022. Are there any interesting whispers coming out of the current data that 3I is likely focused on?
There definitely are persistent little puzzles. One area getting a lot of attention involves beauty quarks, how they decay. They seem to be decaying into certain particles, like muons versus electrons, at slightly different rates than the standard model strictly predicts. It's subtle, but it's sticking around.
Yeah.
And there are also some ongoing measurements related to how the Higgs boson decays specifically into muons that aren't quite lining up perfectly with expectations either. The 3I team, with their focus on anomalies and precision, they're right on the front lines trying to figure out, are these just experimental quirks, or are they the first cracks showing new physics?
So putting it all together, looking forward, it really feels like the work 3i8LS is doing, especially heading into the HLHUC era, is pushing us towards a major fork in the road for physics, maybe for our whole understanding of reality. Can we synthesize the ultimate possibilities here? What are the big potential outcomes?
I think you can boil it down to maybe three broad possibilities. Possibility one, maybe the most anticlimactic for many physicists, is the boring universe. The HLLHC runs for its full duration, collects unprecedented data, and finds nothing fundamentally new. The standard model holds firm. Maybe dark matter and dark energy are just beyond our reach with colliders. That would be a kind of crisis, forcing a major rethink.
Okay, the nothing new scenario. What's the second?
The second is the dream scenario,
Yeah.
New Renaissance. They find clear, undeniable proof of something big. Supersymmetry is confirmed, or they directly produce and identify dark matter particles. That would be huge. It would validate our theories, potentially unlock new technologies, maybe even new energy sources down the line. A whole new chapter for science.
The breakthrough. And the third?
The third, well, let's call it the anomalous revelation, or maybe the Lovecraftian turn, as one source put it. This is where they find something really, truly weird, something that fundamentally shakes our foundations. Maybe evidence of causality violation effects happening before their causes, or, like those theories suggested, unmistakable proof that information, or something else, is being injected into our universe from the outside. Confirmation that reality isn't a closed box.
That third one, wow. It brings us right back to that core ethical question, the one fueling the conspiracies. All the safety reviews say the LHC is safe, based on current physics.
Exactly, based on what we know. But the whole point of 3I's work is to find what we don't know. What if their discoveries reveal that our current understanding of things like space-time stability or vacuum energy is just wrong, or incomplete in a dangerous way? What if poking holes in reality doesn't guarantee they always seal up perfectly? The potential message they decode could be anything from a blueprint for the future to a warning sign.
So the 3i8LS team, they're down there with these incredible tools, searching for answers, for some kind of signal in the echoes of the Big Bang.
They are searching for a glimmer of meaning in that primordial fire. Which leads us to maybe the final thought to leave you, the listener, with. The hunt is undeniably on. And as one source vividly put it, we are all, whether we know it or not, part of the experiment. So what does that really mean? What does it mean to be living inside an experiment where the possible outcomes range from confirming our current reality to potentially witnessing the birth of a completely new one?